so now we have a rectangle, has dimensions x plus 10 and 2x plus 3. The area of the rectangle is 54 centimeters squared. What do we know about our formula for area? Right? It's length times width. When I multiply this times this, what number am I supposed to get?
54.
All right, so we know that 54 equals x plus 10 times 2x minus 3. So, because we know that, we need to figure out what x is. But this is a scenario where we have to expand, collect all of our like terms, then solve for x, right? So we got to do all that inside work first. We got to FOIL this out, and then we're going to have our number c in our ax squared plus b at x plus c. Okay, that number c. Then we're going to subtract 54 from that, and then we're going to have a number we can work with. Then we're going to find the roots. Then we can say what x is going to be.
Okay.
So we might even have an inadmissible number. Aha! All right, so let's look. X times 2x? 2x squared. Okay. 10 times 2x? 20x. Okay. X times negative 3?
Negative 3x.
And then negative 3 times 10? All right. There's still 54 is waiting here to join the party. Now 54 can come on over, right? Parents aren't home. So we'll go over here, and then we're going to subtract 54 from both sides. And then we'll put these two guys together as well. Plus 17x. And then we have 84.
Why did you subtract 54?
Because we want to make this side 0, right? Okay. Now we're able to figure out what the roots of this are. What might be a convenient thing to do? Well, actually, that's not going to help us anyways. Okay. So now we got to figure out, well, 2 times negative 84 is negative 168. So two things that multiply to be negative 168, but add up to become 17. Factors do exist, especially in this section. They're all friendly factors, so you're going to find a factor. Whenever I have a number, it's not like I know every single factor. I'll just play with some numbers. Just play with some numbers. Sorry? That multiply to become negative 168, but add up to become 17. Just play with a couple numbers and see what you get. Hey, that's why you're in town. 24 and negative 7. Okay? I like that. I didn't teach you last year, but you're bringing it. This is great. All right, so x plus 24. So 4 here. Almost looks like a 9. And then x minus 7. That's what you said?
Yeah.
Okay, x minus 7. All right. So what can x be? When I take this quantity and set it equal to 0, what is x? All right, so x equals negative 24. Okay. When I take this quantity and set it equal to 0, what is x? 7. Okay. What can x be?
7.
Why not negative 24?
Because there's no
Negative area.
There you go. Right? We're talking about a thing. We can't have a negative dimension in a triangle unless we're talking about a hypertriangle. Or this is a cube or a square, right? Unless we're talking about hypersquare in hypersquare land, magic square town, fourth dimensional something. I don't know. Yeah? All right, so you get it?
No, okay, I thought that you couldn't do that kind of factoring unless the x squared was 1, like the coefficient. Yeah, the coefficient.
We factored, we skipped a step, didn't we? And then we left some stuff out, didn't we?
You have to multiply.
We totally skipped a step. You didn't stop me.
main factor.
It just hurt my heart. All right, so we totally skipped a step here, guys.
Didn't you do multiply 2 by 84?
There you go. We multiplied 2 by 84, and then we got two numbers. But what does that mean?
Do you have to keep the two x plus one?
We're factoring by grouping. That's what you're trying to say as well. Okay, so we're factoring by grouping. This whole part here, we just went in the wrong direction. We like totally skipped a step.
I'm pretty sure it's like that.
Okay. So we did get two numbers, but that doesn't fit into this process. Even though this looks pretty convenient at the end, but we need to do everything that. Okay. Let's get rid of that. Okay. So 2x squared. Okay. Let's put our 24 over here. Why not? Sure. 2x squared plus 24x, okay, minus 7x minus 84. Okay. Over here I can factor out a 2x. So I'm going to have 2x. And then inside I'm going to have x. And I'm going to have plus 12. Okay. Over here I can factor out a 7. Okay. And then, yeah, that's right. Okay. Because
You factor out negative stuff?
I factor out a negative 7, right? And then I'm going to have an x. And I'm going to have a plus 12. Right? 5 times 12 is 60. 6 times 12 is 72. 7 times 12 is 84. So that's how we get there. So that works. Now, we look at this as a larger group. We factor out this quantity here, x plus 12. Okay, and we write what's left, 2x minus 7. Okay, this is way better now. Okay. Now, we take this quantity and set it equal to 0. What do we get?
Negative 12.
All right, so we have x equals negative 12, or, wait a second, 7 divided by 2, right? So we take this quantity and set it equal to 0. That means we add 7 to both sides, but then we still have a 2x here, so we have to divide 7 by 2, right?
Wait, it's not negative 6 for the other one? Oh, wait, no.
Negative 7. Good question, good question. So, now this is the thing we have to keep in mind. Just because we have a number that's negative doesn't necessarily automatically mean it's inadmissible. It's only inadmissible if when we substitute it in, it still is a negative value. Because we're talking about a rectangle, so we cannot have a negative dimension. Okay? Just as like if we were talking about time, we couldn't have negative time. If we're talking about an object, we can't have a negative side length. Okay? So, but it only becomes inadmissible when I sub it in and check. So you have to sub in and check. You can't just discount it because it's negative. Because this number here might be 14, right? If this number is 14, well, negative 12 plus 14, it's 2. We still have a positive side length, so that's not an issue. So just keep that in mind, okay? You got to sub in and check. Sub and check. Okay, and then when we do that, we'll see, oh, you know what? That becomes a negative, so we can't even use that. So we can identify this as extraneous. Extraneous. Okay, therefore, that's what my x is at 7 over 2. Okay.
What if both of them work?
If both of them work, then we have two types of rectangles,
Okay.
right? So if both of them worked, then I would have a rectangle that is negative 12. Let's say that this is larger than that, so that's 14, okay? And then let's say that this is 27, okay? I have negative 12 times this number, let's say it's positive 27. I'm going to get a dimension. But then when I put in this other number, I'm going to get a different dimension, which means that we have two types of rectangles. That's all that means. I could have a rectangle that's like this, I could have a rectangle that's like that. And it would still satisfy the rest of this. In this case, though, when I sub in 12, it doesn't work. I get a negative side length, so this is the only one that it's going to be. And then the other additional question might be, what are the side lengths? So then we would say, oh, I just put this quantity in here, and I say, well, one side length is 10 and 7/2, and then the other side length is 4. Okay, so, but that's not the question that was asked in this, but just keep in mind that that's probably where this stuff sort of goes. Okay? We have half an hour? No. We have 5 minutes. These Thursdays. That's because the math was so amazing. Anyways, let's have. You guys went up to the Osprey yesterday, okay? So let's go 13. Let's go 13 to 20 and number 24. All just factoring, okay? Okay, 13 to 20. And then let's also look back at 4.1 because you may get a question in 4.1 where I say answer this question, but show me the algebra. So like put it into vertex form and then find the roots. So even though you might be able to calculate it on your calculator, you still need to be able to figure it out by straight algebra. Okay? We did the bridge. Okay? We've done almost all these questions, haven't we? Oh.
I understood except for C.
Let's just do 15, okay? So we'll add 15 to that. 15 on page 217.
Try to go to 8.
17. I can. We're not going to see this one yet. This is the discriminant. We have 3 minutes.
That's not going to be on the board, no?
Let's talk about 13.
I was only confused.
Can we talk about 13? Okay. Go like this. So, 13 it says, for what values does the equation x squared plus 6 at x plus some number cross the x-axis? Okay? So, when it says equals 0, when does it cross the x-axis? What does k have to be? And so, when does it touch the x-axis only once? When does it touch the x-axis twice? When does it not touch the x-axis? That's what's going on there. Okay? So, if I put this into vertex form, okay, what is x? Okay, remember this? Like this? Okay? What's my x coordinate of vertex form? What is my? It's -3, right? So we got a 6 divided by 2 times 1, -2 times 1, right? So my x coordinate is -3. What's my y coordinate? So I sub -3 back in. -3 times -3 is 9. So that part becomes 9. Let's just write that down so we don't lose it. -3 times 6 is -18. Okay. Then, -18 and 9, that makes -9. Right? What else is there though that I have when I subbed it back in?
Plus k equals 0.
Plus k. Right? That's my other coordinate. It's -9 plus k.
Did you just find K?
And then you just need to find k for those different scenarios. So I had it on my Desmos yesterday, right? So then we'll go, just 1 second, okay, don't leave yet. So then we'll go x squared plus 6x plus k, add slider. This is great. Look at that. Now we can see what values of k, okay? Here's k at 9. Look, when k is at 9, it just touches the x-axis once, right? Minus 9 plus k, so minus 9 plus 9 is 0. When it's greater than that, when it's less than that, that's how we deal with number 13. Okay?
Is that really question or two?
It might.
So we just have to know, like, we have to find three methods.